energy needed to heat the learning centre and the lodges comes from the lake?
No, I didn't. How's that possible?
Well, it's done by a heat pump, which can absorb energy even at very low temperatures and transfer it to another space. Have you heard of a heat pump?
I've heard that a heat pump works just like a domestic fridge, but in reverse. But to be honest, I don't know how a fridge works.
Well then, that's a great place to start. Let me explain. Here, we have a domestic fridge. Basically, we have a box where we want to keep the inside space colder than the outside space. And so, we need to move the heat that is inside the box to the outside. We do this using heat exchangers. Let's look at the back of the fridge to see more. You can see two loops of pipe here, which are both heat exchangers. One inside the fridge and one outside. The one inside the fridge is known as the evaporator. Inside the evaporator is a refrigerant gas, and the gas absorbs heat from the fridge and its contents. The gas is then pumped at high pressure to the outside heat exchanger, which we call the condenser. The high pressure gas is now quite hot, and as it passes through tubes of the condenser, it cools and gives up its heat energy to the outside room. The cycle continues, taking heat from the inside of the fridge and dissipating it into the room. This is quite wasteful when you think about it, as we don't do anything with the heat energy we have extracted from the fridge. We just let it go.
Okay, thanks. I can now understand how a fridge works. But what about the heat pump taking heat out of Trevassack Lake?
No problem. Let's take a look at the heat pump circuit for the lake. The only difference between this fridge circuit we've just looked at and the Trevassack Lake water source heat pump is where heat is taken from and where it is used. Let's look at the fridge circuit again, but this time as a flow chart. Remember how this works?
Yes, the refrigerant continuously loops around this circuit and transfers the heat from the evaporator to the condenser, and the heat just escapes into the room.
Correct. So now let's look at how we control where the heat comes from and where it goes by wrapping the refrigerant pipes in boxes containing water. We can call these water jackets. If we now connect some pipes to the water jackets around the evaporator as shown, we can take heat from wherever we want to pump around the evaporator. We can take it from the outside air or from the ground. We can also connect the condenser water jacket to whatever circuit we want. We can heat our home or hot water cylinder with the heat we have taken from the evaporator.
So that's basically how an air source heat pump and a ground source heat pump work, yes?
Well done, yes. So, let's now look at the Trevassack Lake water source heat pump. You can see here that the evaporator gets its heat from the various coils which are placed within the lake. Each of the coils is connected to a common pipe which is referred to as a manifold. If the water from the lake is at, say, 5 degrees centigrade, heat is extracted from it and it is returned to the lake at 0 degrees centigrade. This energy is then compressed and transferred to the heating and hot water circuits that serve the learning centre and the lodges. So, now let's have a look at some photos of the actual pond mats when they were being installed, and the heat pump itself that is located in the plant room. This first photo shows the heat exchanger coils, which we call pond mats, before they were positioned in the lake. And here are several photos showing the coils, or pond mats, being pulled into position. Just simple coils of plastic pipe, really. You may recall our flow chart, where all of the coils are joined to a common manifold. This is one of the manifolds installed below ground. The main flow and return pipes now pass from the manifolds to the heat pump circuits which are located within the plant room. And here are the two heat pumps located in the plant room. You will see that they look a little like domestic fridges from the outside. The inside is of course the fridge cycle in reverse, taking heat from the lake via the evaporator, compressing it, and transferring the heat energy to the heating and hot water circuits of the learning centre.
That explains a lot. Thank you.
No problem at all.